All right, so we're going to look at Bronsted Lowry acid-base theory. If you've ever watched Bad Boys or whatever, it was Mark Lowry. I love that. Bronsted Lowry, acids and bases. So if we take a look down here, make sure you have this sheet ready. It's got the notes up top. There's not very many of them. This gets confusing very quickly because it's opposites again. It's just like pH versus POH. So we know an acid to have a hydrogen at the beginning usually, but more importantly, we've always called it a hydrogen ion donor. Basically, these give up hydrogen ions in bases, while an OH is nice to see at the end. We've defined them as a hydrogen ion acceptor. They take in hydrogen. They accept the hydrogens. So, if we're looking at this, if we look at this, the reactant side, HS plus NH2, HS has become S. So did it donate or did it receive a hydrogen? Well, it lost a hydrogen, so that means that that is the hydrogen ion donor, which makes it the acid, because it gave up a hydrogen ion. Now NH2 negative has become NH3. So it has accepted a hydrogen ion. That makes it the base. Well, acids become conjugate bases, and bases become conjugate acids. And that's what this says right here. It's formed when a base gains a hydrogen ion, or it's formed when an acid has donated a hydrogen ion. And the way I look at conjugate acids and bases is if we were to reverse this formula, then the S2 negative is accepting a hydrogen, making it the base on this side. And since this is a product side, these are the conjugates. And the NH3 has donated an H if we go in reverse. So it's an acid, and since it's on the product side, it is a conjugate. So these are the easier of the problems, is to sit here and look, oh, HF has become F negative. So it has donated, and it's an acid. H2O has become H3O, so it is accepted, so it's a base. The acid becomes the conjugate base, and the base becomes the conjugate acid. The H3O, if we go up across the opposite way, has donated, since it's the conjugate acid. The F has accepted, making it the conjugate base. Now, when you look at this, it says, which of the following are conjugate acid-base pairs? So, can H3O, PO4, donate one H and become a PO4 negative 3? No. So that is not a conjugate acid-base pair. Can HSO4 negative 1 donate one H and become SO4 negative 2? Yes. This is the acid, and this is the conjugate base of that acid. Now, a question you might be asking yourself is, how does the negative 1 go to negative 2? Well, if we lose an H, that H has a +1 charge. So if we lose one positive 1 charge here, the new charge of this entire thing is negative 2. Down here it says, write the conjugate acid for the following. So if this is acting as a base, that means it is accepting an H. So we are to write the conjugate acid for that. Well, if we accept an H, now we have two H's. And since we added on a +1 charge, if we were a negative 1, we would now have no net charge. Write the conjugate base for each of the following. The substance is an acid. So H2S is acting as an acid. An acid is a donor. So it has lost one of the H's. So now it is HS. And since it has lost a +1 charge, H, it now becomes, since it's neutral here, it now becomes negatively charged. Good, good.